Alright, second video on matter. This one we're going to talk about the properties of matter. Okay, so we've got our nice little picture here. We have the physical change, the chemical change. Ideally, you've heard of a lot of these things before, but let's go through them anyway. So we have physical properties of matter. Physical properties are observable. You can see them, you can feel them. Physical properties can be measured by observation. So some examples: color, shape, odor, texture. Those are all physical properties of matter. Some more specific ones to chemistry: melting points and boiling points. Melting points, the temperature at which something melts. Boiling point is the temperature at which something boils. We can observe the physical state of matter, solid, liquid, or gas. We can observe or measure the density, the hardness, conductivity, and lots more of physical properties. These are just a non-exhaustive list of physical properties. So take a minute now. I want you to think about the physical properties of aluminum and steel. So we have packaging made out of aluminum, we have packaging made out of steel. Which one do you think is best suited for a lightweight can of pop? And which is best suited for a can of green beans that needs to be stacked on piles for months? Take a minute now and maybe do a little bit of research on what are some properties of aluminum and what are some properties of steel. So maybe you've compiled your list. Aluminum and steel are both metals. Steel is an alloy made up of iron and possibly carbon and a few other things. Aluminum, just an element. Okay? Each one has its pros and cons for what kind of material it's or what function it has. But here's two properties. Aluminum doesn't really corrode well. Okay? Steel corrodes pretty easily. And by not corroding well, I mean not as quickly. So aluminum can be corroded, but not necessarily as quickly and under the same conditions as steel. Steel corrodes really well, so bridges are often rusting, and that is a perpetual issue of America. Okay? Aluminum has a low density, whereas steel has a pretty high density. So if you're thinking about weight of packaging, your pop can is probably going to be better off being really lightweight as opposed to being made out of steel, which is very heavy. But bridges are much better off having these nice, strong, heavy densities as opposed to this very lightweight aluminum. Aluminum is highly malleable, so you can pound it into nice thin sheets. Steel is not quite as malleable. Steel is less thermally conductive, whereas aluminum is highly thermally conductive. That means you can cool a can of pop very quickly and easily, whereas maybe not so quickly and easily for steel. Steel has a very high melting point, which means it takes a lot of energy to prepare it and melt it and mold it into the shape you want, whereas aluminum has a low melting point, so you can recycle aluminum very easily. Steel can be recycled, but not as easily. So steel is really good for making cans for your green beans, because those cans are going to be stacked on top of each other for a long, long time. And maybe your can of pop wants to be lightweight, or should be lightweight, so that you can carry it around and have your can of pop wherever you want. There's a little link here down at the bottom. If you go to my website and you download the PowerPoint, you can click on that link and read more about aluminum and steel. So physical properties are unique to a substance. Okay, so they have unique physical properties that define it. Here's a picture of something that is blown up many, many times. The substance is much smaller than this. It has white, small crystals. The melting point is 212 degrees Fahrenheit. The boiling point is 1621 degrees Fahrenheit. And I think these units actually might not be correct in looking at those. It doesn't have an odor. The density should have units, my fault. If you look up these properties, you'll find that they match with table salt. So table salt has unique properties compared to, say, sugar. Sugar melts at a much lower temperature. That's why I don't think this is correct, because I'm pretty sure you cannot melt salt at that temperature. That's not right. Alright, so we've discussed physical properties, but there's also chemical properties. Two examples would be flammability and reactivity. A chemical property is something that you can't really just observe by looking at it. You actually have to allow the thing to react in order to observe the physical property, or the chemical property. So flammable, you're not going to know it's flammable until you set it on fire, right? Reactive, you're not going to know it's reactive until you let it react. Each of these ends up changing the identity of the substance. So it is a chemical property. Okay, so that's kind of what I'm saying here on this slide. Physical properties are observable. You can measure them without changing the identity of the substance. Chemical properties can only be observed by changing the substance identity. Okay. So here's some physical and chemical properties. We have rubbing alcohol. You probably have that in your cabinets at home. Red food dye. Some of your food that you ate today might have had red food dye in it. And baking soda. You probably all got that in your cabinets at home. Physical properties. Rubbing alcohol is a clear liquid. Red dye is a red liquid. Baking soda is a white powder. Those are physical properties. You could do other physical properties like measuring the melting point or the boiling point. You could measure the density of rubbing alcohol or the red dye or the baking soda. Those are all physical properties that can be measured without changing the identity of the substance. Chemical properties, though, rubbing alcohol is flammable. You're only going to know that it's flammable by setting it on fire. Please don't do that at home. Rubbing alcohol is highly flammable and can be very dangerous. But in the process of setting the rubbing alcohol on fire, it now is turned into carbon dioxide and water. Well, that's not rubbing alcohol anymore, the isopropyl alcohol. It's changed the identity. Red dye can react with chlorine and lose its color. Essentially, it's being bleached. Okay? So by changing that, by reacting with the chlorine, it's changing the structure of the molecule, and it no longer has the red color. Okay? Baking soda, it is reactive with vinegar. By reacting it with vinegar, you're changing it into you're changing it into water and a salt, sodium acetate, and carbon dioxide gas. You're releasing carbon dioxide gas, you've got water, you have sodium acetate. Those are all new chemical substances. It's no longer baking soda. Okay? So the reaction is definitely changing the identity. So when we're looking at changes in matter, if there's a new substance formed that has new properties, it's going to be a chemical change. Some examples are like baking a cake or spoiling milk. There's new, different substances. Okay? If it's like a physical change, you still have the same substance with the same properties. You haven't changed the identity at all. An example is breaking off a piece of chalk. It's still chalk, it's just smaller pieces. Changing the state of matter of something is still a physical change. Ice versus water, still H2O. The identity is not changed. Anytime you change the state of matter, it is a physical change. So here are some examples. Identify these as physical or chemical. Cutting your hair, something I need to do. Probably a physical change. Still going to be Mrs. Bilkey. Still going to be Mrs. Bilkey's hair. Just shorter. Someday. Dissolving sugar in water. Is it still sugar? Is it still water? Yeah, you could boil off all the water and leave the sugar behind. It's still the same. That's a physical change. If you burn a block of wood, not so physical anymore. Now you're turning the wood into carbon dioxide and water and all kinds of other substances, and you're leaving back ash. not wood anymore. The identity has changed, the properties have changed. So that's got to be chemical. Rust forming on a metal. The metal is actually reacting with oxygen and with water in the atmosphere and turning into iron oxide. Or if you've got a different metal that's rusting, maybe it's copper oxide, tin oxide. It's no longer the same substance. It's a lot flakier, it's brittle, it breaks apart. That substance has totally new properties. Not shiny anymore, not ductile, not malleable. It's now a totally different substance. That's going to be a chemical change. If we're separating a mixture, you're still maintaining the identity of each of the pieces of the mixture. Just now they're separated. That's going to be a physical change. When a battery dies, well, inside a battery there's a chemical reaction that's occurring. And at some point, the chemical reaction can no longer proceed, so the battery dies. I think that's a chemical change. So we've got cutting your hair is physical, dissolving sugar in water is physical, burning wood, that's chemical, rust forming is chemical, separating a mixture is physical, and a battery dies is chemical. Alright, I think you're ready for your homework. So you're going to get this homework assignment, physical versus chemical change. You've got a list. Identify them as physical or chemical. Okay, the instructions up here give you a reminder on what kind of change is what. On the back side, we have physical versus chemical properties. You just need to classify each of the properties below as either physical or chemical. You can put a check mark or an X or whatever you like to do. That's it, guys. Have fun.